Our ancestry can be detected not only in our genes, but also in our metabolism, a new Yale-led study has found. In an analysis of the metabolic profiles of healthy American babies, researchers found surprising differences among ethnic groups which may help make screening for inherited metabolic disorders, cystic fibrosis, or hypothyroidism much more accurate than traditional genetic disease screens. We don't want to miss a baby who is potentially sick, and we don't want to put families through the burdens and concerns that can stem from a false positive test, said Kurt Scarf, Associate Professor of Genetics at Yale School of Medicine and senior author of the study published in the journal. For the study, Scarf and colleagues analyzed data collected from more than 400,000 babies, representing 17 self-reported ethnic groups, who were part of California's newborn screening program. The question was not only of academic interest but of concern to pediatricians. For instance, it is known that babies of African heritage are more likely to have elevated blood biomarkers indicating cystic fibrosis than babies born to white parents, even though babies born to white parents are far more likely to eventually develop the disease. Researchers hope that using ancestry to interpret these differences in marker levels might offer more accurate ways to assess risks than traditional genetic tests. People of African heritage are also known to have greater genetic diversity than those from ethnic groups because they are descendants of the world's oldest ancestral population. Modern humans emigrated from Africa to regions across the planet. Other ethnic groups are descendants of these original migrants, and have enough variation in their DNA to make them genetically identifiable. For instance, while there is a clear delineation between genetic variants among African Americans and Americans of European descent, researchers found that metabolically these two groups are more closely related. Conversely, while people of Japanese and Chinese descent, for instance, are closely related genetically, the researchers found larger differences in their metabolic profiles. Where people are separated by circumstances, such as language or lifestyles, then differences in metabolism are greater than genetic variations. Scarf cautions that more work needs to be done before findings can be applied clinically. Researchers only analyzed 41 out of many hundreds of metabolites and relied on parents' own reports of their ethnic heritage, which might not always correspond to reality. This is just a first snapshot, but understanding our metabolic ancestry has a promising future, Scarf said. Make a difference. Sponsored opportunity StorySource. Materials provided by Yale University. Original written by Bill Hathaway. Note: content may be edited for style and length. Molecular Genetics and Metabolism, 2022, 137, 3, 292 doi, 10. 1016, J. YMGME. 2022. 10.002 Cite this page, Yale University. Metabolism, not genes, may offer more insight into risk of some diseases. Science Daily. https://ift. tt. kenjupg. Accessed October 17, 2022. Thanks for watching. Please subscribe my channel for more videos.